We are going to start now the next lecture, lecture 6 of chapter 2, class 11th, mathematics, relations and functions. So in this lecture we will study about some real functions and operations on these functions. So a function is said to be a real function if it is defined from a set x to y and both these sets x and y, these are the subsets of R. There is another term that you may come across, that is real valued function. When we are saying real valued function, it means its value is real. We are talking about y is a subset of R, that is the answers that we are getting after applying that function, they are real. But these functions we are saying these are real functions. In this, the domain is a subset of R and codomain is also a subset of R. So the first example we have given over here, it is this function fx is given, that is fx is equal to 3x cube minus 5x square plus 10, and we have to find the value of f of x minus 1. It means what we have to do, in place of this x we have to write x minus 1. So when we replace all these values, we are saying f of x minus 1, that is equal to 3 into x minus 1 cube minus 5 into x minus 1 square plus 10. We have applied the formula of x minus 1 cube over here. We have applied the formula of x minus 1 square over here. And on collecting the like terms, we obtain the final answer in the form, it is 3x square minus 14, 3x cube minus 14x square plus 19x plus 2. So this is the value of f of x minus 1. Next we have is, if fx is equal to x plus 1 by x, we have to show that fx cube, that is equal to f of x cube plus 3 times f of 1 by x. So what is the meaning of this term, f of x cube? We are saying this is fx, that is equal to x plus 1 by x. So what is f of x cube? It means x plus 1 by x cube. We are cubing both sides of this equation. Second thing we are talking about, it is f of x cube. So what we are doing over here, it is this term x cube is there. So what we have to do, in place of x, now we are having it as x cube. So in place of x we are writing it is x cube plus 1 by x cube. The last term we have it is 3 times f of 1 by x. Now what this term 1 by x means over here, that in place of x we have to write 1 by x. In place of x we are writing it is 1 by x. In place of this x we are writing it is 1 by x. So this term will be equal to x. So if we add both these terms, the answer, it is 3 over here, so 3 is multiplied over here, this 3 is over here. So we are saying when we add both these terms, we will get f of x cube plus 3 times f of 1 by x, that is equal to x cube plus 1 by x cube plus 3 times x plus 1 by x. So if we look at this term over here, and if we open this whole square, it is x plus 1 by x whole cube. The value we will have it is x cube plus 1 by x cube plus 3 times x into 1 by x into x plus 1 by x. These two values get cancelled. So the answer we are getting it is x cube plus 1 by x cube plus 3 times x plus 1 by x. So we are saying the left hand side is equal to right hand side, and we obtain this answer. Next is, if fx is equal to x minus 1 over x plus 1, where x is not equal to minus 1, Why this condition is given to us? Because if x is equal to minus 1, this denominator will become 0. We have to prove that f of x, that is equal to minus 1 by x. So what f of x means? This is basically the composition of function, but we are not considering it as composition. We are just writing in place of fx writing. We are writing this term over here. It is x minus 1 over x plus 1. These things we will study in detail when we will talk about the composition of functions. But right now we are not using this term and we are trying to solve this. So this will be equal to, what is the value over here? It is in place of this x we are talking about, these two x we are talking about, we are substituting this value over here. So we will get it is x minus 1 over x plus 1 minus 1 over x minus 1 over x plus 1 plus 1. So taking the LCM, we get it is x minus 1 minus x minus 1 over x plus 1 divided by x minus 1 plus x plus 1 over x plus 1. And on solving this, we will get it is this x gets cancelled over here, this 1 gets cancelled over here. So in the numerator part, we are left with this minus 2 over x plus 1 into x plus 1 over 2x. So the answer we get, that is equal to minus 1 over x, and this is what we have to prove. Next is, if y is equal to fx is equal to ax minus b over bx minus a, and it is given that a square is not equal to b square, we have to prove that x is equal to f of y. So what this f of y means? We are saying what is given to us is that y is equal to f of x. So in place of y, we can write it as f of x. So this value will become equal to f of, what is fx? It is ax minus b over bx minus a. Now again, we are substituting in place of x. We have it is ax minus b over bx plus a. This is the value of fx that we have. So we are replacing this x, these x we are talking about, we are replacing these x with this value, and the answer we are obtaining, this is equal to a into ax minus b over bx minus a minus b over b into ax minus b over bx minus a minus a. On solving these values, on solving this value, we will obtain, if you will again take the LCM over here, the LCM we have it is bx minus a, and this numerator you will get a square x minus ab, and this value you will get it is minus b square x plus ab divided by these values you will get it is abx minus b square minus abx plus a square upon bx minus a. So this bx minus a gets cancelled. From the numerator part, ab gets cancelled, abx gets cancelled. So what we are left with is, from this term we are saying we are left with a square x minus b square x over a square minus b square. Taking x common, we are writing a square minus b square over a square minus b square, and it is given to us that a square is not equal to b square. These two terms we are cancelling, and the answer we are obtaining, that is equal to x. So we have started with the value f of y, we have written it is f of x, and we have obtained that this is equal to x, and this is what we have to prove, that f of y is equal to x. Next we have is, if fx is equal to x minus 1 over x plus 1, we have to find the value of f of 2x. So that will be 2x minus 1 over 2x plus 1, and we are saying that this is equal to 3 times fx, that is x minus 1 over x plus 1 plus 1 divided by fx plus 3, it is x minus 1 over x plus 1 plus 3. So on solving this term, we are writing it is 3x minus 3 plus x plus 1 divided by x plus 1 over, it is x minus 1 plus 3x plus 3 over x plus 1. X plus 1 gets cancelled. So the answer we are left from this term, it is equal to 4x minus 2 divided by 4x plus 2. So dividing the numerator and denominator by 2, we will get this is equal to f of 2x. So this is the right hand side and this is the left hand side. Both of these values, these are equal to each other. Next we have is let f and g be functions. These functions, these are defined like fx is equal to x minus 3 and gx is the function. It is a piecewise function given to us and it is defined in this form. We have to find the value of k. This value we are saying such that fx is equal to gx for all x belongs to R. We are saying at all x, these values, these are equal. So what is given to us is that when x is equal to minus 3, we are calculating the values of both the functions. We are saying f of minus 3, that will be equal to minus 3 minus 3, that is equal to minus 6. And the value of gx we will have, that is we are talking about g of minus 3, that will be equal to, we are saying when x is equal to minus 3, the value we have it equal to k, and it is given that at x is equal to minus 3, both these values, these are equal because they are equal at every point of their domains, or we are saying for every real value r, it means both these values, these are equal. So the value of k we obtain, that is equal to minus 6. Next we have is fx is equal to 1 over 1 minus x. We have to show that f of fx is equal to x. So we are saying this value we are calculating, this f of fx we are talking about. Now this fx over here, we are saying we substitute the value of this fx as 1 over x minus 1. So the answer we obtain, it is f of 1 over 1 minus x. Now again we are using this function over here, so we are writing it is f of 1 over 1 minus 1 over 1 minus x. This is equal to f of 1 over 1 minus x minus 1 over 1 minus x, and this value is equal to f of 1 minus x over minus x, and this value is equal to f of x minus 1 over x. Again, if we put this in the given function, we will obtain this is equal to, we have substituted this value in the given function and we obtain that this is equal to in place of this f of 1 over this, we have to substitute this value. So we are writing it is 1 over 1 minus x minus 1 over x. The answer we obtain, it is 1 over x minus x plus 1 over x. So the answer we obtain, that is equal to x, and this is what we have to prove. Next is if fx is equal to 2x over 1 minus x square, show that f of tan theta is equal to sine of 2 theta. So in place of x we have to write it is tan theta. So we get it is f of tan theta, that is equal to 2 tan theta over 1 plus tan square theta. This is equal to 2 tan theta over secant square theta. This is equal to 2 sine theta over cos theta into cos square theta. So this cos theta and this get cancelled, and this is equal to 2 sine theta cos theta and this value is equal to sine 2 theta. Next we have is, if y is equal to fx is equal to 3x plus 1 over 5x minus 3, we have to prove that x is equal to f of y. So the value of y that we have from this equation, it is equal to fx. So it means what we have to prove is that x is equal to f of fx. So this is equal to 3 into 3x plus 1 over 5x minus 3 plus 1 over 5 into 3x plus 1 over 5x minus 3 minus 3. So when we multiply these terms, we will get 9x plus 3 plus 5x minus 3 upon, it is 15x plus 5 minus 15x plus 9. This is equal to 14x by 14, and that is equal to x, and this is what we have to prove. We are saying we have considered over here the left hand side, we have solved this value, and this comes out to be equal to right hand side, hence the proof. Now next we are talking about, it is the operations on functions, and the first function that we have, it is sum of two real functions. So suppose we are talking about the two functions. One is the function f, we are saying, that is defined from the closed interval 0, 5 to r, and its definition, it is given to be fx is equal to x square. Suppose there is another function g that is defined from the set of natural number to r, and it is defined like gx is equal to x cube. Now we are saying there are two functions f and g. The domain of first function, it is, we are writing it is d1. The domain of second function, it is d2, where d1 and d2, these are subsets of r. That is, both these functions, these are real functions. Then we are defining a function f plus g. First thing, the domain of this function, this is the definition that we have. The domain of this function will be the intersection of these two sets d1 and d2. So what is intersection of these two sets? We are saying it is 0, 5 intersection n elements of this set. 0 is not a natural number. The first natural number, it is 1, 2, 3, 4 and 5. So the domain of f plus g, that is equal to intersection of these two sets. This thing is mentioned over here, d1 intersection d2 to r. The codomain, it is r over here. These are real valued functions, we are saying. These are real functions, we are saying. And how it is defined? It is f plus g of x is equal to fx plus gx for all x belongs to domain of this. You can view it is like a new function we are defining, hx, that is equal to fx plus gx. We are saying this is equal to f plus g of x. So what this thing means, in this case, if we have to calculate the value over here, so we are saying that f plus g of x, that is equal to fx. Value of fx we have, it is x square. The value of gx we have, it is x cube. It is x square plus x cube. Now the value of x, they can be 1, 2, 3, 4 and 5. These are the possible values of x that can have, and this is how the function is defined. So if we have to calculate the value of f plus g of 3, we are saying in place of x we are substituting this value, the answer we are getting, it is 3 square plus 3 cube. If we have to calculate the value of f plus g of say 1.5, we are saying this thing is not possible, because 1.5, it is not the element of the domain of the function f plus g. Next we are saying the next operation we have, it is difference of two real functions. Just as in case of the addition, we are saying we are having two functions f and g. Domain of these functions, these are d1, d2. Both these functions, these are real functions. Then f minus g, it has the domain d1 intersection d2 and the codomain is r. Then f minus g is defined as fx minus gx. So in this case, if we have to calculate the function f minus g, we are saying this f minus g, it is the function whose domain is 0, 5 intersection n. This set is equal to 1, 2, 3, 4, 5. This new function hx that we have obtained, we are saying, say this function is h. So what is the value of h of 3? We are saying it is hx. This is the new function we are talking about. It is equal to fx minus gx. We are writing this h in place of f minus g. So we are saying its value is x square minus x cube. So the answer we obtain it is 3 square minus 3 cube. So answer in this case it is 3 square minus 3 cube. If we have to calculate h of 0, we are saying it is not possible to calculate h of 0 because the domain of h does not contain 0. It means we are saying it is not possible to calculate f minus g of 0. This is not the feasible value. The next operation we have, it is the multiplication of two real functions. Again, the same thing we are considering. We have a function f from d1 to r. We have a function g from d2 to r. d1, d2, these are subsets of r. So both the function, these are the real functions. Then we are saying that f into g, the domain of this function is again intersection of d1 and d2. It is d1 intersection d2, it is the domain of this function. Then f into g of x, that is equal to fx into gx. So in this case, we are saying f into g, this is a function defined from closed interval 0, 5 intersection n to r. And how it is defined? F of g of x, that is equal to fx into gx. So we are saying it is x cube into x square. So it is equal to x raised to the power 5. So if we have to calculate the value of fg of 3 or fg of say 5, then the answer we have it is 5 raised to the power 5. This is the value of this function because the domain of this function we have the elements 1, 2, 3, 4 and 5. That is, this is the interval 0 to 5. Interval 0 to 5 means it has all real numbers from 0 to 5. We are taking the intersection with the natural numbers. So the answer we are obtaining it is this set over here. The next operation we have it is the quotient of two real functions. Now we are saying there are two functions. One is the function f from whose domain is d1 to real line. There is another function g whose domain is d2 to and the codomain it is r. Both d1, d2, these are subsets of r. So we are defining a function f by g and the domain of this function is the d1 intersection d2, this set, minus all those values of x for which this denominator we are talking about. This denominator we are saying this is equal to 0. So from the intersection of d1 and d2, we are further removing the points for which the denominator is 0 and we have defined this function like f by g of x, that is equal to fx upon gx for all x in d. So if we are talking about say the function f that is defined from say r to r and the value of this function it is fx is equal to say x plus 2, there is another function g that is defined from r to r, and we are saying the gx, it is defined like x square minus, or we are writing in place of x square, say we are saying it is x minus 2. Now when we are defining the function f by g, the domain of that function is r intersection r minus those point of x for which gx is equal to 0. We are equating gx is equal to 0. We are saying x is equal to 2. So we are saying this r intersection r is r minus the point 2. So this is the domain of, and the codomain it is r. So what we get is f by g of x, that is equal to fx over gx. What is fx? It is x plus 2. What is gx? It is x minus 2. So we are saying this f over g is defined from r minus 2 to r, and the value of f over g of x, that is equal to x plus 2 over x minus 2. Next definition we have, it is the reciprocal of a function. We are saying f is a function defined from d1 to r, and we are defining another function f of 1 by f whose domain is the domain of the function d1 minus all those point x for which f of x is equal to 0. You can just consider it like the quotient function for, we are saying this is the quotient function for, there is a function identity function, that is a constant function we are talking about, that is fx is equal to, there is a function we are saying, say gx is equal to 1, and the value of g there from r to r. There is another function f, we are saying its domain is d1 to r. So what is g over f? That is equal to 1 over f. The domain of this function will be the d1 minus all those point x for which fx is equal to 0. So this is mentioned over here. We are saying this 1 over f, it has the domain d, where d is d1 minus all those point x for which fx is equal to 0, and it is defined like 1 over 1 by 1 over fx. So in this case, if we are talking about this function fx, and we have to define the function 1 by f, so we are saying 1 by f has the domain all real numbers minus 2, because if we equate this term x plus 2, if we equate it equal to 0, we will get x is equal to minus 2. So we are saying that from real numbers we have removed the number minus 2. This is the domain, and the codomain we have, it is r, and the definition of function 1 by fx, that will be equal to 1 over x plus 2. This is the definition of this function. The next operation we have over here, it is the scalar multiplication of a function. So scalar means we are talking about any number over here, any real number. So suppose alpha be a scalar, that is alpha is a real number. Wherever the term scalar we are using in this chapter, if we mean to say we are talking about a real number, there is a function f from d to r. Then the function alpha f, this is a new function. Its domain will be the domain of the function f, codomain will be r, and it is defined like alpha f of x is equal to alpha into f of x. Suppose we are talking about this function g. We are talking about this function g. We want to calculate the value of 3g, this function we are talking about. So it is defined from r to r. The domain and codomain, they do not change. So we are saying 3 times g of x, that is equal to 3 times gx. And what is value of gx? It is 3 times x minus 2. So this is the definition of the function we are talking about, that 3 times g of x, that is equal to 3 times x minus 2, that is 3 times g of x. Next we are given two functions over here. One is the function f defined from r to r, and fx is given to be equal to x square. Second is the function g that is defined from r to r, and it is gx is equal to 2x plus 1. We have to calculate the values of f plus g, f minus g, f into g, and f upon g. So first thing we have is that the domain of the function f, it is r, domain of the function g, it is r. So intersection of both these domain, that will be equal to r, and this domain r, it will work for this first case, this second case, this third case, and in this fourth case the domain will be r minus all those point x for which gx is equal to 0. What is the value of gx? The value of gx, we have it is 2x plus 1 is equal to 0. So we are saying it is x is equal to minus 1 by 2. So what we get is this set will become r minus 1 by 2. So we are saying the domain of the function f by g, that will be r minus 1 by 2 to r. This is the domain of this function. And the domain of all these functions, f plus g of x, f minus g of x, f into g of x, in all these cases the domain will be r. So when we are defining f plus g, we are saying the domain of this function, it is r, the codomain it is r, and the definition we have it is f plus g of x, that is equal to fx plus gx, and the answer we obtain, that is equal to x square plus 2x plus 1. When we are talking about fx minus gx, the domain is r to r. Fx minus gx will be x square minus 2x minus 1. When we are talking about fx into gx, the domain will be same, r to r. We are saying f into g of x, that is equal to fx into gx. What is fx over here? It is x square, and gx is 2x plus 1. Last we have is fx over gx. We have mentioned over here that the domain of this function is r minus 1 by 2, and the ranges or codomain it is r. So we are saying that f over g of x, that is equal to x square over 2x plus 1, and the domain and codomain of these functions, these are mentioned over here. So it means that the denominator, basically what we are saying, that the denominator is not equal to 0. This thing gives us denominator is not equal to 0, that we cannot put the value of x for which x is equal to minus 1 by 2. Next we are given the function fx is equal to square root of x and gx is equal to x, be two functions defined over the set of non-negative real numbers. Non-negative real number means we are talking about the interval 0 to infinity. We have to calculate the value of fx plus gx, f minus g of x, fg into x, and f over g of x. So both these functions, these are defined for this. So the domain for first three parts, that is 0 comma infinity intersection 0 comma infinity, that is equal to 0 comma infinity. For the last part, we are saying we have to remove from this the elements x for which gx is equal to 0. Gx has the value x is equal to 0. It means we have to remove the point 0 from it. We are saying we are removing the point 0 from it. Removing the point 0 means now the domain of f by g, the domain of this function will be open interval 0 to infinity. In this case, this interval it is closed. In this case, the interval it is open, and the codomain we have it is equal to r. So the domain of the function f plus g, f minus g, and f into g, it is closed interval 0 to infinity. That is all non-negative real numbers, and the domain of the function f over g, these are the positive real numbers. Now when we are talking about the function f plus g of x, the answer we have it is fx plus gx. So it is equal to square root of x plus x. When we are talking about f minus g of x, the answer we have it is square root of x minus x. When we are saying f into g of x, the answer we have square root of x into x, that is equal to x raised to the power 3 by 2. The domain of all these functions, the domain is non-negative reals. Last we have it is f over g of x. So that will be equal to square root of x over x. So the domain of this function is equal to, the domain of this function we are saying it is the positive real numbers. When we are talking about f plus g of x, the domain is positive real numbers. Next we have is the two functions f and g be real functions defined by fx is equal to square root of x minus 1 and gx is equal to square root of x plus 1. So first of all we have to write the domain of these functions. Now we are saying, look at this term over here. This term is defined only when x minus 1 is greater than equal to 0. Otherwise it is square root of a negative number and it will not remain a real function. Means we are talking about the answers should be real, and answers will be real only when x is greater than 0. X minus 1 is greater than 0, so we get x is greater than equal to 1. So the domain of the function f we have, it is closed interval 1 to infinity. The answer we are saying it is R. When we are talking about this gx over here, we are saying this again, this value x plus 1 should be greater than equal to 0. So we get x is greater than equal to minus 1. So the domain of the function g is minus 1 comma infinity, and the codomain we are saying it is equal to R. Now we are talking about the numbers. It is 0, 1, minus 1. 1 we are talking about this interval 1 to infinity. Second we are talking about the interval minus 1 to infinity. We are talking about the numbers 1 to infinity, minus 1 to infinity. So what is common part over here? This 1 is included over here. So the intersection of the interval 1 comma infinity with the interval minus 1 comma infinity, that is equal to 1 comma infinity. So it means f plus g, f minus g and f into g, all these functions, they have the domain closed interval 1 comma this closed at 1. This interval it is closed at 1. When we are talking about the function f over g, we have to remove those elements from this interval for which gx is equal to 0. It means square root of x plus 1 is equal to 0. So this means x is equal to minus 1. So we are saying that whenever we substitute the values from the domain of this function over here, this number is never 0. So we are saying the domain of f by g is also equal to this. Basically we are saying the interval 1 comma infinity is there. We have to remove the element minus 1. This interval does not contain the element minus 1. So the answer we are obtaining over here, it is interval 1 comma infinity. So in all these cases, for all these cases, f plus g of x, f minus g of x, f into g of x and f by g of x, the domain of the all these function, it is 1 to infinity. And the definition of these function, it is given over here. When we are saying it is f plus g of x, we are saying it is equal to fx plus gx. What is fx? It is square root of x minus 1 plus square root of x plus 1. When we are talking about f minus g of x, we are getting minus sign over here. When we are talking about f into g of x, the answer we are getting, it is square root of x minus 1 into square root of x plus 1. So that is equal to square root of x square minus 1. Finally, when we are talking about f by g of x, we have already seen that the domain of this function is 1 to infinity, and the answer we will get, it is square root of x minus 1 over square root of x plus 1. So this is the value of the function f by g of x. Next we have is, let R positive be the set of all positive real numbers. We are saying R positive be the set of all positive real numbers. We have defined a function f from R positive to R, and the function is log x to the base e. We have to find the range of f. We have to find those values of x for which x belongs to R positive, set of positive real numbers, and fx is equal to minus 2. So first of all, we are calculating the range of this function, and we have already seen the graph of this function log x, and from there we know that it can attain any value r. We have seen the graph of this function log x in our previous lecture, and from that graph we have mentioned that it can attain any value r. So we are saying the range of this function, it is equal to r. Next we have, when we have to calculate the value of that value of x for which log e of x is equal to minus 2. So we are saying that the value of x that we will have, that is equal to e raised to the power minus 2. So we have to write the set. So we are saying we have to write the element x such that fx is equal to minus 2. So the answer is the set containing the element e raised to the power minus 2. Next we have to calculate the value of f of, we have to check whether f of xy is equal to f of x plus f of y. So what is f of xy? F of xy means we are talking about this function fx is equal to log ex. So f of xy, that will be equal to log to the base e into xy. This is equal to log to the base ex plus log to the base e y. This is by the properties of log, we are saying log ex y, that is equal to log to the base ex plus log to the base e y. For these properties you can refer to the videos related to logarithms, and we are saying this is equal to f of x plus f of y. Now the next question we have, the function that is given to be f is defined from R to R, and fx is equal to 2 raised to the power x. Again we have to calculate the range of this function. So we are saying the function we have, it is fx is equal to 2 raised to the power x. So this is the exponential function, and we know that this number, this 2 raised to the power x, this can never be equal to 0, and we know that this is always greater than 0. It has always the positive value. So the range we have, it is r positive, or we are writing it is the open interval 0 to infinity, or we are saying it is set of all positive real numbers. This is the r positive we are talking about. Second is, we have to find the set x such that fx is equal to 1. We are talking about fx that is equal to 2 raised to power x is equal to 1. It means x is equal to 0. This thing is possible only when we take the value of x is equal to 0. So when we are talking about this set, the answer we have, it is the set with the element 0. Next we have to check whether f of x plus y, this is equal to f of x into f of y or not. So we are substituting the value in this left hand side we are considering. We are saying it is f of x plus y. So that is equal to 2 raised to the power x plus y. That is equal to 2 raised to power x into 2 raised to power y. This is equal to f of x into f of y. And this is what we are saying, that f of x plus y, this is equal to f of x into f of y. Hence, this third result is proved over here. This third result is proved.